Welcome back to your favorite pre-calculus course. Good to see you guys. We're going to take a look at applications and models of trigonometry today, especially involving right triangles. We're going to solve some real-life problems involving right triangles. We're going to look at some involving directional bearings and so forth. But let's start with some right triangles. Let's say you got an angle A that's 20 degrees as shown here, and you got the side B equals 15. If you remember, when you draw these things, um, standard is that if I call this angle A, then the side opposite would be little a, okay? If this is angle B, then that side opposite is going to be little b, and so on. The right angle there, capital C, lowercase c for your hypotenuse, okay? So we go ahead and put in there that that's 20 degrees, angle A. Put in side length, lowercase b, which is 15, and then we look at this and we say, well, let's use some right triangle trig. I have angle A. I have the adjacent side to that, the lowercase b, which is 15. How about we find C, the hypotenuse there. So which one are we going to use? We're going to use the old cosine, since cosine is adjacent over hypotenuse, okay? And then you go ahead and solve that. So you want to multiply, you got to get that C on top, don't you? So let's multiply by C both sides here. So I got C times the cosine of 20 degrees, C times the cosine of 20 degrees. Of course, cosine of 20 degrees is just some number. So let's divide out that number, that cosine 20 degrees. Okay, so 15 divided by whatever cosine of 20 degrees is, that's our answer. I think I got it right here. 15.96 what that ends up being. 15.96. Okay, so now we got C, 15.96. Well, let's go ahead and use A, and let's find side length, lowercase a there, that side opposite, okay? So I say, let's use the old sine. No, you know what, let me try the old tangent. Let's involve the lowercase b again. So let's go tangent 20 degrees is opposite over the adjacent, which is 15. Then we just go ahead and multiply both sides by 15. And we'll be done with this. Okay, so 15 times tangent of 20 degrees. And make sure that your calculator's in degree mode, of course. And that should spit out 5.46. Okay. So there's the side length A, side length C. The only thing we're missing is angle B. Of course, angle B, since all the interior angles of a triangle add up to 180, that's got to be, angle B's got to be 70 degrees. Okay. And now we've solved everything on that triangle there. Okay. All right, let's do application here. Safety regulation S, I need to take that out, states that the maximum angle of elevation for a rescue ladder is 72 degrees. Fire department's longest ladder is 110. What's the maximum safe rescue height? Let's make this visual. We always like to be visual, right? So we got our ground here. We got this building that goes up here, right? And then we got this ladder that's its maximum height is 110 feet, and this angle that it makes, 72 degrees, right? The maximum angle for a rescue is 72 degrees off of this, okay? 110 feet. What's the maximum safe rescue height, right? So what's this H? We'll call it height there. Okay, of course we made a 90-degree angle with the ground in that building. Okay, so we go ahead and we say, hey, you know what, 72 degrees, I want the side opposite. I have my hypotenuse. Which one is opposite over hypotenuse? That's the old sine. So I use the sine function here. Sine 72 degrees is opposite over hypotenuse. Multiply both sides by that 110 times 110 times 110, and there's your maximum safe rescue height. 110 times the sine of 72, 104.62. 104.62, 104.62 feet. Okay. So that's a good little problem there. Let's move on here. Now, trigonometry and bearings. So in surveying and navigation, directions are oftentimes given in these bearing situation where you're going off the north-south axis, okay? So if they say a boat goes from port like south 30 degrees east, okay, you want to think, okay, I'm going south, and how far off of south am I going? Which direction off of there? I'm going east, okay? So south, there's your little 30 degrees. South 30 degrees east. That's the direction I'm going for south 30 degrees east. Okay, let's do it for north. Now you're going north, but which way are you going off of that north? You're going 70 degrees west. So you're off 70 degrees this time. 70 degrees off the north. Okay, so that's your direction that you're going. North 70 degrees west. Okay. Well, more south 45 degrees west, so I'm going south, right? But I'm 45 degrees west off of that south. 45 degrees west there. 45 degrees. Okay, so that's the direction we're taking right there for south 45 degrees west. Okay, so that's a little bit trig and bearings. And now